All right. I think we're live. I gotta fix my video. I apologize for, let me silence my phone. I apologize for the delay. I was having some technical difficulties with my webcam. Looks like I definitely am live though. If I mute this. Okay. And also I apologize, the echo in my apartment is absurd. I should adjust my camera. All right, let's fix this. Properties. Filters. Add a filter. Add crop. All right, let's get rid of. Not too much? No, that's fine. And then get rid of this. Perfect. Ish. All right, folks, how's it going? No, yeah, it's starting now. Apologize, I was just a couple minutes late. And I apologize for the hiatus from live streaming. The J porting from C to C++ will resume. Oh my God, that water is delicious. Hope everybody's having a great day, depending on what time it is. It's either the morning or the afternoon or the evening. It is 5 p.m. or 5:05 Eastern Standard Time. And I've been meaning to do this live stream for like a week now. But I just moved into this new place, and so there's been a lot of stuff going on. So what we're going to do is we're going to solve this in, I don't know, n different languages, at least 5. We're going to start in C++. And I think this is an extremely interesting problem. I discussed it first with the programming languages meetup. Someone asked, is it still active? Definitely it's still active. We took a one week break. We'll be back on Monday. God, that water's good. Apologize for my overexcitement about the water. Yeah, so the programming languages, I guess if people are interested, meetup.com. Of course, I'm not logged in. If we just Google meetup, programming languages, virtual meetup. Yeah, we should. Am I going to have to log in to see this? No, I'm not. You can go join here if you're interested. We're working our way through category theory for programmers. Also, ADSP, the podcast. Going strong. How many episodes? 20, 25, technically 26 because we're 0 indexed. Episode went out today. It was fire. It was a longer episode, lasted an hour, and we were talking about a missing reduction algorithm. Anyways, so lots of stuff going on, but today for the next 2 hours we're going to be solving this, and then next live stream I do will probably be back to the J programming. Am I job hunting? No, I just like solving leak code questions. Yeah. People always ask me, how do you develop your algorithm intuition, or how do you become like an algorithm expert? Leak code's like, people use it for job interview prep, but it's also a fantastic way to practice your algorithms, as we're about to see. God, that water. All right, so let's hop into it. We're going to start with C++. I'll read the problem statement. It's been on screen for a while, so I'm sure all of you have read it. And we'll come back to this problem statement in case people are hopping in later on. So we're given a 0 index string S that has lowercase English letters in its even indices and digits in its odd indices. So here's our example. We zoom in a little bit more. A1, C1, E1. And honestly, it's so confusing the way they state these problems. Basically, what happens is you have to replace every digit with a letter, and the letter is equal to the previous character plus the digits. So it's the letter that's, in this case, 1 after A, which is B, and 1 after C, which is D, and 1 after E, which is F. So the result is going to be A, B, C, D, E, F. And in this one, it's a little bit more involved. 1 after A is going to be B, 2 after B is going to be D, 3 after C is going to be F, 4 after D is going to be H, and then there's nothing after E. So you're going to end up with A, B, B, D, C, F, D, H, E. And yeah, so pretty straightforward. And we're going to do something that is, we gotta turn off Slack on my, actually we just gotta mute my other computer is what we gotta do. We're going to start by doing something that I don't endorse. Should we do this in Godbolt? What does chat think? I'm probably like delayed by 10 or 20 seconds. But we can start in LeetCode and just program in here. But if people want, we can hop over to Godbolt. And we're going to code this. We're going to solve this first with a for loop. Dun dun dun. Just because I'm sure if we went and looked at the solutions, which we won't yet, maybe we'll look at them after. Most of them are going to be done with a for loop. So very sad. And we can't use a range-based for loop because we need the index, right? We need to be able to refer back to like the most, the previous character, which requires an index. So let's do this. So technically we can start at 1. And so actually we're just going to do this super naively. Auto t equals s. And then at the end of the day, we're going to return t. And I is less than s dot size plus plus. Technically, we can actually go I plus equals 2, right? Which is fine. And in the body of this loop, basically what we're going to do is we are going to set t of I to be equal to t of I minus 1 plus t of I, and we need to convert this. Do we need to convert this? Yes, we do, because you can't add a character. You're going to need to convert this to a integer, and the easiest way to do that, I think, is just by that. Is that right? No. That's, I think, right. Does this work? Did I mess up? Someone asked in the chat, does these coding platforms help with jobs? 100%. I mean, first interview I ever had at a technology company was with Bloomberg, and they actually conducted their interview through a CoderPad or CodePad, which is like a HackerRank website. So, and I've verbatim had questions asked in interviews that were directly from LeetCode, or maybe they ended up on LeetCode because they came from an interview. So let's test, run the code. Look at that. We solved it. Should we just submit it? Let's use all the test cases and see if it works. My answer looks right. Okay, well let's submit. Let's see if it's accepted. Should we go look at the details? Let's go look at the details. How fast was it? I guess it doesn't really tell you. I guess you have to do it during the, I actually don't know what this is telling me. Accepted solutions runtime distribution. Who cares? So we solved the problem. You don't need to copy S to T. I mean, you don't need to, but it's the easiest way to solve this. if you weren't going to copy S to T, you'd have to deal with the even indices. All right, so solution 1 done. Let's go put this in our GitHub. I thought I already had GitHub open, but let's go to LeetCode. What is this? This is technically from a bi-weekly contest, and so this is what, P1844. So we're going to add, create new file. What is it? Let's just copy this. Whoops. And then we call this .cpp, and we need to problem. So this solution should make everybody sad because we're using a for loop. Although I'm sure I'm going to get some comments that say, oh, it's the simplest. So let's copy and paste this. Actually, let's get rid of the tab first. And we're going to call this solution numero uno. So the question is for the chat, and I'll wait for people to chime in. What algorithm is this? What algorithm can we use in the C++ standard library header in order to solve this? And actually, there's 2 different algorithms. Oh, I wonder if post, am I able to change it? Am I able to change it? I don't think I can change the latency. Yeah, once it started. I should have set, I'm a noob once again because it's been so long since I've live streamed. I should have set it to ultra low because I think that there's like a 20-second delay. But while I'm waiting for people to guess the algorithm, Taylor says some sort of scan. That's definitely one of the algorithms. And hello, Joao, long time no see as well. So yes, Rack 1507 says, I don't know any C++, but it looks like a scan to me. So that was my first solution that I thought of. I didn't actually. This is the first time I've written the for loop, and I thought of this as you can solve this using a partial sum, aka a scan. So we name our algorithms poorly from time to time in C++, and what you can do. So technically, we can go auto t equals. Actually, is it still? It's still easier just to do the copy. And then we're going to return t, and we're going to replace this for loop with a call to std partial sum. So our input sequence is cbegin, and we're going to go to the end. And we can actually start at +1 if we wanted to, but it's fine for this purpose. Our output is going to be t.begin. Can't be c because we're going to be writing to it. And then we need a, what do we need? We need a binary operation that's going to perform basically this. And so if we copy, well, so actually we're not going to copy. We're going to do this as previous Let me know if you want me to go close my balcony window too, because I know there's sirens in the background, but maybe it adds a little bit of ambiance. Although it's crazy how loud it is, because I'm on the 52nd floor. Like, it sounds like the siren is literally right outside. Previous and current are what these two things stand for, and we're going to return if is alpha. We're just going to return C. Otherwise, we're going to return the previous plus C minus 0, I believe, if I got this right. So let's see if this works. Run code. Your input, your answer. Looks like I crushed it. So, Taylor and Rack 1507, you are both correct that this is a scam. They're coming to arrest me for using loops. Probably. That's a, yeah, don't use for loops. But what's awesome about this problem statement is that I would argue, so we'll call this solution number 2, is that I'm going to argue that this is actually the incorrect algorithm. Like, you can solve it using this. Why is this better than a loop? Because loops are not loops. Well, there's a number of reasons. Personally, in this case, I don't think the previous solution, like, it didn't show you what you were doing. You have to, like, you know, look at all the I minus 1, you know, you got to look at the plus 2. Here, you see there's a scan. Okay, and then you can just look what's inside the lambda. And there's so many other for loops that are, like, slightly different than this, that are a completely different algorithm. And, like, being able to discern the difference between two different for loops is so much harder than being able to discern the difference between two different pieces of code that use different algorithms. Yeah, we're going to get to APL in a bit. I got to speed up. We're already at 20 minutes in. But so I'm going to argue that this is the wrong algorithm. The correct algorithm, and this is because for a scan, you are carrying state with you that is of arbitrary or, like, variadic length. But for this problem, we only actually need the previous element. Like, we have a fixed size of a window that we need in order to do our unary operation on each character. And given that is the case, we can actually solve this using an algorithm called adjacent difference, which is it's like the worst named algorithm. It's actually the second worst named algorithm. Mismatch, in my opinion, is the worst named algorithm. But it's honestly a toss-up. And this basically is going to give us our, you know, previous and current, and we can basically do the exact same thing. So I think this is going to write to. So how does this work? If you have A, B, C, A1, C1, it's going to copy the A immediately, and then on your second iteration, A is going to be the previous one. So it's actually going to be, it's not really like previous, it's left and right. But we can leave them as previous and current. And I think actually this might be the exact same code. Let's just try it. I might be mixing up the two. No, okay, it is. It is mixed up. So we need to swap. Technically, if we just do this. Actually, let's think about this. Well, first we can just try, but I'm pretty sure this is not going to work. It did work. Did it? Let's submit it. Let's see. Accept it. But we really shouldn't do that. Because how does this work? You're looking at the A and the 1, and then writing to... and then writing to the next one. I guess it really doesn't matter, and I want to get to the other solutions. But the point being here is that this is a terribly named algorithm, and it's the preferable one. And also, too, if you think about this in like a parallel GPU accelerated algorithm, a scan is a lot less efficient than an adjacent difference, because this is basically just a transform over two different indices, which is why this really should be called adjacent transform. In fact, if we go to ISO C++, tapers, and plan, when did it come out? Plan for, there we go. And if you look for adjacent in here, you can see that we're going to be adding adjacent difference, but it's going to be called the correct name, adjacent transform, which is going to be awesome. Anyway, so now we have our 3 C++ solutions. Once again, I forgot to get rid of the tab. This one is the best. And let's just commit that. And now we're going to, let's switch over here. Start solving this in other languages. So the point here being that I really want to get across in this video, when you have a scan, but it actually only has a fixed width, you should always prefer not a scan, but like a windowed reduction. In the serial case, these are going to have comparable performance, I think. But in a device accelerated, aka GPU accelerated environment, this one's going to be a lot more performant. And just don't do this, because you're going to have to use some sort of pragmas in order to GPU accelerate this, whereas this is thrust adjacent difference. You want to GPU accelerate this code, you just go and switch your namespace from thrust to from std to thrust, and poof, now you have GPU accelerated code. Hello to the person that sent a heart in the chat. So this is dope, and thanks to Ben Dean / Dr. Mason for the conversations that I have. I talked to Ben when we were at C++ Now. So let's do, what are we going to do? Let's do APL next. So let's open Rye. Woo! APL, my favorite language, and see how quickly we can solve this. So A1, C1, and then E1 is going to be S. And so to do a windowed reduction, let's turn boxing on. We just go like that. And then we basically are going to need to replace this comma with some sort of binary operation that is going to check. So first we need is like to check alpha. So I believe that gives us all the letters in the alphabet. That gives us all the lowercase letters in the alphabet, and it's going to be alphabetical if it exists in this. So if we do that, that's not right. Is it the other way around? And then, whoops, that had the same impact. All right, so now we have our little isAlpha function. which is it beautiful? I'm not sure. But we have our is alpha. So I guess it's going to be, because we're going to have to take the first, right? So actually, yeah, we can split this. So yeah, I think it's going to be alpha. And then to do an if statement, so if it is alphabetical, we basically just return it. Otherwise, we need to do something. So and actually, that's not even true. The ones where the digit is actually the first thing. So I'll go away. This one, yeah, we want to. So we're just going to need to get this right. So actually, before let's just error that out. So let's do this. Alpha, comma, omega. So the alpha is definitely the A. I have not tried coding game. So yeah, let's alpha, membership, quad C, quad A. And this is the one where we're actually going to want to do something. So this is going to just be the other one we're going to want omega. And then here we now need to basically convert. So if we do this, right. So basically we need to be converting the A to B, the C to D, and this second E to F, I believe. And so how do we do that? So if we have A and 1, we first want to convert this, and then we want to add the, is this gonna work? Plus, is it the other way around? Yeah, like that. And then we want this to go back to, so UCS is basically a function for converting integers to characters and characters to integers. So if we had actually dual, this would be much nicer, but we do not have dual in APL. So now that we have this, we're going to copy this, and then we're going to go back, and then we're going to put this into here. Alpha in this case is going to be our character, and omega is going to be our number. So if we do this, voila. And then all we need to do is add the first thing to, so we want to, and I'm pretty sure we can turn this into a fork at the end of the day. So that's our solution. And how do we turn this into a fork? We turn it into a fork by getting rid of this, and putting a why did that not work? Yeah, dual, we'll get to dual in a second, but basically it's an operator that's the equivalent of something in J called, hopefully, I'm not sure if there's J developers, because I'm going to need help when it gets to the J solution, of using basically under. So like, hypothetically, you could have something that looked like do this operation under UCS. So you wouldn't have to type UCS twice. Unfortunately, we don't have that though. Yes, this is Ubuntu 18.04. Syntax error. Nice. So what is the function called? Replace digits. And then if we go, woohoo! Isn't APL awesome? And we're gonna go and we're gonna add this to P, replace all the digits. And we're going to do that. This is basically what I do when I create YouTube videos of a bunch of different solutions. What do people think? Do we want to see the other solution? What does the other solution look like with a scan? In fact, can we just... A scan is just that. Quite verbose for APL. I agree. It's pretty long, but that's mostly just because of this. I mean, how many characters is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So 8 of this is, and what is 8 over 30 is 4 over 15 is 2 over 7.5, so that's roughly 2 over 7 is 28.6%, so that's like roughly 30% of this is due to just this quad UCS. Yeah, we can do Haskell. Want to do Haskell next? We can do Haskell next. Yeah, let's do Haskell. Wait, did I commit? I did not commit this. And I need to copy this. Put APL at the end. Preview, and then we'll do J. Oh yeah, we should do Python as well. That's one of the ones I put in the. GHCI, and actually let's. I want. Yeah, that's what I want. Let S equal A1 C1 E1. Huh? What is going on here? Oh, is it double quotes? Sorry, Haskell noob. All right. So there's a function, I believe, import data.list.ht called map adjacent. Which is what we want. So map adjacent is literally the equivalent of the two y's reduce, like ny's reduce in APL, where we had a window of length 2, and it's the same thing as adjacent difference in C++. And so what we can do to demonstrate that map adjacent, can you do that? I don't think that's going to work. What do you do with 2 characters? Okay, so that just creates tuples. So you can see though we've got our pairs of elements now, and so now we're going to have to write a disgusting lambda that is going to do basically our operation. So let's do that, and let's actually just write it on, actually, yeah, we can write it online, it's fine. So it's going to take AB, or should we call it left, right? Double quotes or strings, you should do Java. Yeah, maybe we'll do Java. So what do we want? If is there an alpha? Is alpha? Let's go to Google. Is alpha data car? Import data car. So now we have is alpha true. Perfect. So we come back here. If is alpha, and then we do this for left. Then, and we'll just for now we'll just go else R, which is where we were before. And now we're going to need to figure out how to go from. So this is why Hugel is so insert expletive amazing. We want to go from a car to an int. Unsafe coerce. Is that what we want? Where are the Haskell pros? I mean, we can do this if we need to. That doesn't seem right, though. Like, there's no way you can add numbers to this. Also, too, I guess that's. Or actually, I guess you would go map +2 over cat, and that's not gonna work. Don't use unsafe coerce. What should I use? Let's Google how to convert car to int and int to car in Haskell. You can use from enum. From enum. What's from enum? Ooh, look at that. From enum. Okay, so from enum is going to the integer. So if alpha, then we go from enum. From enum L plus, and then, is this what we need to do? That seems awful. Actually, so let's go enter. So what if we do, does seem like that's what we need. And then now we just need to convert this whole thing and then to enum to go back. Thank you, Taylor. You the best. And then we go to enum. And I'm just messing up my parentheses. So we got one. Let's just copy and paste this to if then else. So that actually seems right. Do I just need parens around this as well? Oops. What the hell? So actually, let's do this. We'll call this should we call this 2int? So we've got one set for there. So this matches that. That matches the left one in front of from enum. And then this one matches to enum. Oh, it is saying couldn't match car with list car. So if we have from enum A plus 2 int 12. Why is this all of a sudden not working? Oh, right, because it's the friggin' these things again. I see. So is this expecting... This is expecting a string, not a character. Which means... Can we just do this? Is this cheating? Yeah, it's sort of cheating. And so let's name this. What are we calling this? We'll just call it create car. And so now our solution is map adjacent create car, or it's not really great because in certain cases we're just copying the car. And then here we need to do a plus of this, and we just want the head of this. Or we don't, because this is going to be a character, not a list. So we need to do that instead. And then we're going to call this let's replace digits equals, and there we go. So let's copy all this garbage. And then I guess we also need the toInt. We'll grab that in a sec. And we'll clean this up in GitHub. Add, create new file. Use toInt on strings and toenum on cars. Oh, okay, so maybe we can clean this up in a sec. Replace digits, and then I guess we don't need any of this. So actually we can do Can we do... Oh, is there someone that's being irritating in the chat? I can nominate someone to be moderator if necessary. And yeah, Joao's saying the fact that C++ typing is weaker makes it easier. Yeah, that's true. I won't disagree with that. So I guess Taylor's saying for 2 int is on strings and 2 enum is on cars. So technically, I think you're saying that I can do 2 enum here, and that's going to work. So let's go double check that. Create car 2 enum, and now, yeah, it does seem to work, pending that sort of auto-populated. So I think this is our full solution. If we go copy this, and if we put HS, that gives us a tiny bit of syntax highlighting. And this is pretty ugly, I would say. I'll make all right, Joel, you get to be you're in charge. I mean, this is okay, but this is pretty ugly, I will say. Yeah, when it comes to strong typing, a lot of times it's amazing for production code, but then when you're just trying to do these little toy examples and you have to coerce everything back and forth, it's a little bit irritating. So yeah, Haskell's done. I'm not really sure if there's anything we should do here. So let's commit this. And what should we do next? Should we do Python quickly? Let's do Python quickly. I actually don't know. So let's kill this. IPython. S equals A1, C1, E1. I don't know where they're rolling reduction. I guess actually the sort of the cutest way to do this is not with an algorithm per se. It's to do zip of S and S, of course. So you can do that. And what we can do is we can do S of 0 plus that. Okay. Doesn't like that for now, but we'll be doing that in a sec. And then inside here, we're going to go for LR in zip, and then L if, you say enter, is alpha? I assume alpha is a function. Alpha is not a function. Is alpha? Is alpha? Come on. Python is alpha. Huh? Oh, it's not a generic, it's a member. Of course it is. So if L dot is alpha, then that is, or so actually no, else L. Yeah, so now we do the, so can we can just go Actually, let's do this elsewhere. So if we have a, if we go int, what? That doesn't work. What if we do that? Really? I don't know how to do Python car, or actually, let's just go string to int. I thought you could just cast. Int. What the hell? So it works for strings, but not for cars. Python. Car to int. CHR and ORD. I actually knew this, I forgot. Stack Overflow for the win. ORD, and then we're going to go plus and then actually, yeah, so what do we do for 1? Is it going to be the same thing? ORD minus ORD. That doesn't seem right. Or actually, yeah, it does. Once again, Python is a more strongly typed language than... There's got to be a better way to do this. Try ORD. I guess we don't, because that's hard-coded, we can just technically type that in there. 48. Well, someone can tell me if there's a cleaner way to do this in the chat. So we copy this, we go back to this, and we replace this expression with that. And this is slightly wrong. So if L is alpha, oh right, because I'm hard coding all this stuff. L, R, and then should this actually be R? Voila. And then if I do the string, really? A generator expression passed to a string is still a generator expression? Seems silly. So how do you go from, I'm sure if I just did list of, really, a string of a list actually gives you, so Python generator expression to string. Sherlock saying, okay, we'll test that in a sec. Oh, join. Yeah, there we go. And then we just go like that, and we're done. Sorry, yeah, so, yeah, Sherlock almost had it. If there was no leg, so you're saying ORD L plus int R. I don't think this works. It does work. Why was I having trouble with this before? Maybe I was passing in a character or something, and I was doing something stupid. So yeah, that actually works way better. And we're done. So there's no algorithm off the top of my head for doing like a map adjacent or an adjacent difference from C++ and Haskell. But we have zip, and then we've got these really nice generator expressions, and we're not using a list comprehension here, but these are like bread and butter things, and they're very, very handy in Python. So create new file. We call this def, place digits, and it's a one-liner. It's almost as short as APL. And that's not too bad. And it's a hash for comments. And we are done. Pretty nice, pretty nice. Yeah. I don't need to oh yeah, you're talking to Joao. Oh no. If you're this is the best, Sherlock. This is the whole point. Doing this live, I can offload half the work to the viewers. So definitely, if folks have comments and that's the thing is I don't. I mean, there's a lot of people sometimes that comment on YouTube videos unconstructively, but people that are actually like, hey, there's a better way to do this. Those are like that's the best kind of code review. Whether it's in the form of a YouTube comment or an actual like PR code review. I mean, people, in my opinion, everyone should listen to Alexander Stepanov, who said like, we all write terrible code. And actually we're missing a return here, which Ambrose just pointed out. Yeah, we just like, we all write terrible code. Which I think is a bit negative, but I think Alexander Stepanov's point is that we're all learning, and when someone points out a better way to do something, you should try not to take that personally and just be like, "Oh, awesome! Now I know a better way to do this, and next time I can use that new tool that's in my toolbox." So we've done. What have we done now? We've done. If I zoom out, you can't even see it because it's so long. Maybe I'll have to start. But this is APL, C++, Haskell, Python. Let us, and Rock 1507 is saying you can do this much more nicely by zipping. So is this like this is every second one, right? Yeah. And then so how does that work? So you're saying basically only apply the transformation on. Actually, I don't understand. How could you? Because you need adjacent pairs, right? It's basically what you do in your APL solution. How do I get this over onto this computer here? I guess I could just open up YouTube. Should we do that? Oh, look, there I am. Okay. Oh, interesting. I wonder if, nah, there's no way YouTube would be able to tell that. Let's copy. So let's try and walk through this. So this first is just going to convert everything to numbers. Then this is so yeah, this is all one expression. I actually don't know what this is doing. This is a not equal scan. Okay, so this is actually a fork where we're doing a let's go back to the chat to see if Rack's saying, because then you don't need to check if it's alphabetical or not, as you already know where the numbers and numbers. Okay, well this just seems, I can't parse this because I'm an APL noob, but this basically just seems to be sort of folding it so that you get every other one, which is a bit confusing. And then it's doing 48 mod. And then it's doing a row-wise or a column-wise plus, or it's actually a column-wise plus scan. Then it's transposing. Then it's raveling. And then it's taking the length. And then this is doing a select from the alphabetical characters. So essentially, how does the 48 mod work? Is that just like a property? 48 times 2 is 96. And 96 wow. Does everybody get that? That 48 corresponds to 0. So if you do 48 modulus, you can actually convert everything into indices that map into the lowercase alphabetical characters. That's nuts. Is it the same thing? 65. What is that? I don't know what Prime, what you're asking. And then Taylor has another Haskell solution using pattern matching. Whoop, that's too low. So I still don't really see. Yeah, it wouldn't work for uppercase. So I still don't really see how this maps to. So basically, what this solution is doing, if I understand correctly, is it's creating the indices that will map into the character array from A to Z lowercase. So how does that map to Python? Because we can't really do that in Python, can we? Yeah, I don't really see. How about Rack? If you can put together the Python solution that you're thinking about, I'll copy it from the chat and we can look at it. What other languages? So we on my slide. Oh yeah, J. Are there J folks? +1 in the chat, because I'm not going to be able to figure out how to do this in J by myself. But let's see how far we can get. So J is the evolved APL. It's a superset. A1, C1, Dn, E. Oh, come on. S equals A1, C1, E1. Okay. And if I'm remembering, voila. So that's how you do a windowed reduction. And here we're going to replace this, I think. That didn't work. How do you do like inline? What's the equivalent? Are there? Yeah, I'm waiting for a J person to tell me what to do here. Domain error. Although, actually, maybe we. What's going on? Oh, because I need an extra. Okay, let's kill this. Yeah, I have no idea how to do like lambdas in J. So maybe this is going to be dead on arrival. Lambdas. J. Problem is, of course, they're not going to call them lambdas. They're going to call them something else. Maybe we should just search for functions. Inline functions. Or maybe if we search for defuns. Nope. Well, let's actually just go to they're called direct definitions. Direct definitions. Can you define them in line? Or do I have to define them separately? I mean, that's what we did for Haskell anyway, so I guess we can do that. So let's see if we can figure this out. How do we go? Like this obviously is not going to work. So how do we go? Let's go to form functions. Search on Nuvoc for, well, so I think we already quasi found that. Oh yeah. So why didn't that work then? Let's try something easier first. Iota 10. So the example they use is x plus y, 10, 20, 30. So that works. It works for a reduction. Is confusing. What if I just go X? Or Y? Y seemed to work. Oh, I see. Is it not a... It's not a binary operation, it's a unary operation? That doesn't make any sense at all. Why would you do that? Right. So that's the left one. And that's the... What the F? Oh. So this is take or first. And so if we reverse this, then we get the last one. But if we use drop in the monadic case, I guess it drops the first, so it's like the equivalent of tail in Haskell. So you end up with a list, which is why the dimensions are different. Yes, the 2 on the side is defining the window size. So yeah, that's hella irritating. Okay, well at least we have a way of accessing the first and last. Try. Yeah, that should work. IO4. Yeah, which is what we expect. Yeah. Okay, let's see. We got 40 minutes left. This should be enough time. So how do we go from how do we go from car to int and int to car? Actually, so I happen to know on nuvoc, if we go down to foreign, probably should be renamed. Doesn't seem like the best. Convert. Yeah, Adrian's pointing out the fork version where it's using the brackets. That also, we could also might be able to use that eventually. Is J space sensitive? In certain cases, I don't know when it is, I just know that for certain cases around like the direct definition double braces, you can run into issues if you don't have like a trailing space or there's some ambiguity, but I don't know the exact details. All right, how do we go from what to what here? Convert to J integers. It sounds promising. I have no idea how to actually use this. So we've got X, N, and Y. Oh yeah, where can I find a link to the problem statement? Sorry, yeah, folks joined late. It's this LeetCode problem, replace all digits with characters. And basically, you're given a string. Can I post this in the chat? I could probably post this in the chat. Maybe not. Does it eat it? Even if it's from me? Oh no, it works. But yeah, basically, you leave all the alphabetical characters the way they are, and the digits, which is every other one, you convert to a character by adding the numeric value to the alphabetical characters. So this becomes A, B, C, D, E, F. Sorry, yeah, I forgot to, I said I was going to check in on the problem statement for folks that were joining. So yeah, let's go back. Has anybody told me how to, has anybody, we're trying to figure this out. Convert from J integers, a numeric Adamer list. I feel like we're in the wrong. This is where we need Bob or Ken. Convert character to int integer. It's just matching two. J software converting to and from integers. Oh, there we go. This could be useful. This could be useful. Execute. All right, apostrophe. Here we go. 12. Hey, one down. Does it now? So does it go the other way? No. All right. So we have to int. Do we have? Do we have, how do we get, lowercase a to 97? Oh, integer to car, and car to int. What the F is this? So I guess that was what we were looking at back here. Zolatan is saying a.i.a, a dot I dot. Woo! How'd you do that? And what if we do a dot I dot 97? Oh, too bad. Sherlock is guessing this. So no. Well, so we do have, so that's the thing is that I was hoping we were going to be able to use dual, which is, or under, which is the equivalent of what I mentioned earlier in APL as dual, which doesn't exist. But that's the thing is like, if J does not have an equivalent of UCS, which is like a round trip, like it goes both from character to int and int to character, like the ASCII value, then we can't use under. So what if we swap these? It's a random guess. No, it doesn't work. Brace yourselves, fully tacit APL solution incoming. Oh man, my shoulders are sore. All right, we're getting close. So we've got this. We've got this, and so all we need to know is how to go back. I'm not really sure what this was about, but let's see if so this is integer to car, CI to 1. Integer to car. What the? I don't think that worked. Can't under infer how to undo the pre-processing? Maybe? I'm not sure. Let's give that a shot. So under, I believe, is this. So under reverse. So say we have 4, 3, 2, 1, and if we want to do a what do we want to do here? Actually, let's just do 111. If we do a plus scan, you get that. But if you do a plus scan under reverse, it happens from right to left, because first you reverse it, then you do the scan, and then you reverse it again. So if we go A dot, I dot, and then I go A, and then I go 1 plus domain error. Alright, so first of all, let's check to see that. So that does work. Under syntax error, '97. So I actually don't understand what's going on here. Under, and then we go 1 plus CI297. A is an array of ASCII characters. It can be indexed and rotated. Oh, I see. I see. Right. Makes sense. So we have that one. Should we just use these? Use these crazy, whoops. So we've got CI2, 98, and C2I. Car? How do you do a car literal? Nope. Two car to integer. Integer to two car to integer. Two car to int. Why don't they show examples? S. Yeah, sleep well, Sherlock. Thanks for the help. So I guess they're saying if I go CI2, right, that gives you back. So I think this does work. Okay, so let's do this. Let's just butcher this. I also don't know how to do. How do you do like a conditional? so let's just search for if dot. Side. If something do something else something end. Okay. I don't think your tacit solution ever came through. But I think we're close. We're close. So if oh yeah, how do we get the lowercase characters? Do we have to do something like this? Take 97 plus iota 26. Is that really the shortest way? APL jealousy. Yeah, if you posted your solution, Rack, I don't think, yeah, YouTube let it through. So actually, I think. So yeah, this is like membership because it's close to the APL membership glyph. So we can call this is alpha equals and then this is y is alpha 1. All right, so if is alpha of y, do if do and then dot dot dot, actually else dot 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 end. So for now, let's just do this. Wah, wah, wah. Oh, my if is missing a period. Oh, look at that. Okay. Why is that? I would expect this to be a tiny bit different. So this is 2s. So yeah, we do want it to be the last one, so that this part's correct now. And now this is the one where we want to do like C to I to C, blah, blah, blah kind of stuff. So, so let's do, the second one is going to be, so this is, we need to go back to our handy dandy CI2. So integer to car or to car to int. So C2I, C2I. That gets us actually no, so this is the one that we want to execute, which was apostrophe dot, right? And then we want to add this to what was C to I of the first of Y. And then from this, we want to go CI2. Oh, too bad. Length error, C2I. So let's just, if we have A1 and we go like that, and then we go like that, and then we go C2I take of A1. So yeah, it's upset about this. C2I. What happened? To car to int. C2I is expecting 2 characters. Should we just see if we can replace? Yeah, let's just do that. Why is this? Why is it like that? Ravel raise. Ten. Is it? I think this is because it's giving us back 2 characters again. Yeah. What is with this 2 characters thing? So if we have 98, how do we do just a pick? Oh wait, that's the wrong order. Or actually, yeah, we can do the tilde. 5? Hey! And then we want to... Wow, that made me sad. But clearly this is not like the array programming. I'm trying to force like my C++ solution into this. So as rack 1507, good night, Joao. Yeah, there's definitely a way nicer way to do this. But we will call it there because I've only got 15 minutes left, and we should try and do the Clojure solution really quickly. But I might run out of time. IJS. So this is... So I'm not actually sure, will this work? If we... Yeah, it does. And technically we need to... Well, is alpha give me the definition? It will. Good enough. Good enough. We'll come back and revisit that maybe when I make my YouTube video. I'll try and get a nicer version. All right, we've got 11 minutes. Do you think we can do Clojure in 11 minutes? Does LeetCode support Clojure now? It does not. It supports Racket. So let's just go to JDoodle because I don't have Clojure set up. And I have not done Clojure in a while. Whoa. Got it. Defen, replace digits, S, and then, how do we do this? Just to test this. Is this going to work? Digits, A1, C1, E1, execute. Nice. All right, how are we going to do this? Do we have a Clojure docs partition? This is not overlapping though. Do we have zip? We don't have zip. How do we do adjacent? How do we do adjacent elements? I think technically we can just map. So if we just map, how are we going to do this? Well, let's go back to what we had, and let's do a test list, and then we want to map. We want to map percent. I can't even remember if that's the right syntax. %2 on L, and then drop 1L. I don't even know if drop. I'm just guessing. Drop. Is it Clojure? I'm gonna run out of time. Anonymous function. Percent. It was percent then. So how did I mess that up? Yeah, %1, %2. I nailed it. Oh wait, I didn't test my test. Print line test of. I also don't remember if I need commas. Oh, look at that. Okay. So 3, 5, and 7 is what we expect. Okay, okay. So, do we have an is alpha? Character is letter. Damn. Yeah, my Python solution is here. Well, I think we're gonna run out of time here. Stay tuned for the Clojure solution. Let's in the last 5 minutes here. I'm curious. Hot, most votes. Straightforward codes. So yeah, this is the Java solution that we wrote initially in C++. This is the Python solution, but instead of using a generator expression, it just uses a for loop, and it doesn't use zipping, so it does this arrange, which you shouldn't do this anyways because there's an algorithm called, or a function called enumerate. So pretty sad. Simple replace. So yeah, it's basically the C++ solution that we had, except there. Oh, I see what. Earlier in the chat, someone said you don't need to create a new string. You can just in place and then return it because you're doing a copy here. C++. It's basically what we did initially. Java, C++, and Python. Same Java solution with the for loop. C++ with the for loop. Ah, look at this, Python. Actually did something very similar to what we did, except not iterating over every element, or is iterating over every one, but it's using indices, which I still think is a bit more confusing than zipping and just destructuring immediately. Let's take a look at a couple more. Same solution, just a for loop. Same solution, just a for loop. Missing the function declaration and the highlighting, syntax highlighting. Absolutely no syntax highlighting here. How did this get voted up twice? It's a crime. Oh, you know what we should do? How many people? There's 35 people watching. Which one should we post? And then anyone with a LeetCode account can go and upvote my my solution. We should do C++. Post. Where do we go? Post. New. Know your algorithms. Three C++ solutions. C++. Algorithms. Zoom out a little bit, and then we go up, up, up. Up, up, up. Up, up, up. Up, up, up. Up, up. Yeah, I guess technically should we get rid of all these, just leave it. It's fine. Post. All right, folks. Let's go and, let's go and, the tagging was off. What did I mess up on the tagging? Oh, my tags did disappear. C++. Boop. And algorithms. Boop. Update. All right, let's go. Let's hit refresh. Did anybody upvote? Nope. Let's go. There's 36 of you. Let's get to number 1. Oh man, this is gonna be sad. It's gonna be sad if nobody upvotes. Newest. Only got 1 view. All right, I gotta go. It's 1 minute past 7, folks. Although, I guess, yeah, there's a delay by like 20 seconds, I guess, so. Well, there's been 2 views at least. Well, thanks for tuning in. I need a haircut. This has been fun. I'll probably make a YouTube video condensing this 2-hour thing into 10 minutes and add a couple other languages. Oh, look at that. We got 1 upvote. Our path to the top of the leaderboard. Oh, we're on the front page now. Still only 1 upvote. Have I done Rust? No, I haven't done Rust. I can add a Rust solution to the YouTube video when I get around to making it. And yeah, thanks for tuning in. Hopefully you learned something. Know your algorithms, adjacent difference, aka adjacent transform, aka map adjacent, is preferable over scans like partial sum. And yeah, that's basically the point of this video. And we'll revisit this in a couple days to see if I make it to the top. Enjoy the rest of your Friday and have a great weekend. And yeah, like I said, I'll be back to the J live streams sometime this month once I get a little bit more settled in here. So hope everybody has a great night, and we'll catch you in the next one.